So all our triangles at the moment have been pretty much restricted to right angle triangles. And obviously there's a lot more triangles than that, so we need some more rules. The first one is our sine rule. So here's just a general triangle. What I do is drop in the perpendicular heights. It creates two right angle triangles, and we know how to handle right angle triangles when it comes to trig. So I could say, well, look, I know h over c, that's going to be the sine of b. So that perpendicular height would be equal to whatever c times sine b is. Now, if I look at it in the right-hand side, I could also say h over b is the sine of c. So h is also b sine c. Well, it's the same h. Therefore, c sine b must equal b sine c. Not how we normally see the sine rule. Play around with it. There we go. c over sine c is b over sine b. In fact, it would also be true to be a over sine a. Remember, they were just random letters that I've got there. So that is always true, that ratio will remain the same. All right, let's just do a couple of quick examples. Here's one where we have to find a side. So h over sine h is q over sine q. Subbing in, multiply out, bit of calculator work, and 45.8. If they don't tell me how to round off, I usually just match the question. Whatever degree of accuracy they've done, that's the degree of accuracy I'll give my answer to. It could be an angle that we have to find. It's all right, we'll do this one. In this case, it's angle y, so we'll have sine y over y equals sine z over z. So I've turned the sine rule upside down, if you like, because whatever I want to find, I put in the top of the fraction. Subbing in, multiply out, and we get 46 degrees, 58 minutes. And I know that will be correct. However, when we're using the sine rule, we need to check, does your answer make sense? Now, the last one it did. But of course, remember, sine is positive in both the first and the second quadrant. So it might be an obtuse angle. Now, in that last example, I knew it couldn't be, because one of the angles that was marked in was already obtuse. And you can't have two obtuse angles in one triangle. So remember those sorts of things. The angle sum, of course, has to be 180. So as I was saying, if you've already got one obtuse angle in the triangle, you know you can't have another one. But this, the largest angle will always be opposite the largest side. It's also true that the smallest is opposite the smallest and the middle one's opposite the middle one. So here's a triangle. I'm going to draw in what we call a circumcircle. Now, why do I bring this up? Because the sine rule is actually more than those ratios. It is actually that. A over sine A equals B over sine B equals C over sine C equals the diameter of the circumcircle that goes around the triangle. Area of a triangle. Of course, we know it's half base times height, but what if we don't know the height? Well, let's say half A times H, but we know H over B could be sine C, so H is B sine C, which allows us to use this formula. So we don't have to know the perpendicular height. As long as we've got two sides and the included angle, we can find the area of the triangle. Of course, it means then that not only is it half AB sine C, it would also be a half BC sine A and half AC sine B. So we use this one as an example, and in this case, a half dm sine f. So subbing in, bit of calculator work, and there we are, 25.47 units squared, of course, because we're talking about an area. So 6 eyes on our sine rule.